Welcome, everybody. Today we're going to be talking about solving air gap problems the cloud-native way with Zarf. I am Austin Abro. I work for Defense Unicorns. I'm a Zarf maintainer. Zarf was previously created by Defense Unicorns and owned. We recently donated it to OpenSSF. So yeah, thanks for joining. So first, I kind of want to start out with why is air gap Kubernetes hard? So you might think, hey, can I just load all my images into a flash drive, plug them in, get my cluster going, get everything running? But you might take for granted a lot of things that are missing in the air gap. You might not have like foundational tools like Docker, kubectl, a K8s cluster runtime, a Git server, especially an OCI registry, which we're going to talk about more, but obviously very crucial for an air gap. And so you might think like, OK, I mirror Red Hat's Yum, and then I download Docker through that with a Yum install. But that mirror might go to Google to download things. And so we live in a connected world. Most everything assumes you can have access to the internet. You can probably install kubectl just as a static Go binary, but there's just a lot of complications you run into. And then when you set up your environment, you want to know what's in it. You want SBOMs. You want a consistent setup. And it's just hard to track if you're manually bringing in on a hard disk without tooling around it what's actually going into the air gap. And on top of that, when you're in the air gap, you don't have internet, you don't have ChatGPT, you don't have Stack Overflow. And so when you run into these issues, who do you call? You might be in the air gap and not super technical. You might be in the air gap in a submarine, water gapped. And the skill set you need to run a submarine is very different than the skill set you need to run a Kubernetes cluster. So we want this to be as simple as possible. When you're in the air gap, you actually have pretty good security. I believe a common saying is the most secure system is at the bottom of the ocean. And so you have that, but where do we get the UX from? How do we make that easy to run? And then there's the registry problem, especially with Kubernetes. A cluster needs a registry to pull images, but many air-gapped environments are not going to have that registry available. You might think, let's do Docker run the distribution image, which is great, but again, how do we get Docker? What about HA? Are we going to run our registry that our cluster is relying on just from a Docker run? We might want more around it. And for HA, you might think, let's set up the cluster or let's set up the registry in the cluster, excuse me. But you need a registry to set up a registry. So chicken, meat, egg. How do we solve this? And enter Zarf, well, again, which is what I work on. So Zarf allows you to set up a cluster and a registry with two binaries, Zarf and the Zarf init package. It allows you to declaratively state what you bring into the air gap to create and deploy what we call Zarf packages, which I'm going to get into a little bit later. And it also bakes in tools such as kubectl, K9's the monitoring tool, and Sift for SBOMs, just to give you everything you need in two binaries plus the binaries for the packages that we'll see in a sec. So initially, this slide was a lot of words, but it didn't really make sense. It's still going to be a bit complex, but just for fun, I'm going to kind of walk through how Zarf init works and how we solve this chicken and egg. So I'm going to do a demo in a sec, but we have Zarf init, which is going to create a Rust injector config map, which is the simplest possible OCI registry. It's going to serve exactly one image. And this injector is a Rust binary that is sent to the cluster through a config map. And then we pull a pod. We create a pod from an existing image in the cluster, because we know the cluster probably has some kube system images. We expose that simplest possible OCI registry through a node port service. We also send in to this pod a volume of config maps that put together create a registry image, usually distribution. We then spin up a long-living registry to point to that injector, the injector service, and then we update it to point to itself. So we've solved the chicken and the egg. Very confusing. You don't need to understand that to understand Zarf, but it is a unique showing of what's required sometimes in the air gap to get spun up. And once you do Zarf init, which we're going to do in a sec, you have a Zarfed cluster, we'll say. And so the Zarf registry and optional Git server are created. We also kind of built in have an easy way to spin up a Git server with Git. And this is pretty crucial for anyone that's doing Flux or Argo workflows in the air gap. You need those Git repositories there. And then we have a mutating webhook we call the Zarf agent to mutate the image field on pods to point to the Zarf registry. And one thing that I think is really huge about this is you want your manifests, you want your Helm charts to be the same as what's running in your connected environments. You want to be able to test those on the connected side before you deploy into the disconnected side, because it's going to be a lot easier to debug. It's going to be a lot easier to Google search and test things out when you're on the connected side, obviously, and you just don't want to have discrepancies between your environments. So let's look at what Zarf init looks like. I have a kind cluster up. The Zarf init package does deploy a K3s cluster optionally, but I'm just, for simplicity's sake, going to use the kind cluster I got here. And we're going to run Zarf init. So usually when you're in the air gap, you would need to bring in the Zarf init package with you. Those are the 2 binaries. However, in this case, I already have it cached locally. And let's watch what goes on in the cluster while we do this. So for fun, I'll do the Zarf tools K9s, which I talked about earlier. Get K9s up. And I will spin up the Git server. And we can kind of look as we go. But we're going to add the config maps to the cluster that create the registry, or create the injector, excuse me, along with the registry image. And now we have a Docker registry. It's running distribution, pulling from the ejector. Once that's running, we're going to restart it and spin up a Docker registry that is going to restart and point to itself. This part takes like 30 seconds, probably another like 10 seconds, and we're good. Good water break from me. Cool, and then we're pushing up the agent image to that long-lived registry we now have. We're pushing up the git image, shout out git free software that makes it easy to run kind of this built-in Git server. And cool, that's spun up now, we're good. So we have this cluster up, we have this Zarf cluster, but obviously it doesn't really do much. We still need to get our actual applications into the air gap. So now we're going to talk about Zarf packages. Essentially, it consists of a binary that runs your entire application, or that is able to launch your entire application. So all the Kubernetes manifests, customizations, and Helm charts are going to be in there. The OCI images, which is very crucial, pushing those to the Zarf registry. Git repositories, again, for GitOps workflows like Flux and Argo CD, which the agent, I think I forgot to mention before, also will mutate those Git repositories to point to the Zarf Git server. And then files and commands to run on the host. These aren't, as Kubernetes native, we try to target Kubernetes explicitly, but we do need them for doing things such as creating the cluster runtime, like I talked about the K3s setup that is available in the Zarf init package. And so we'll get into examples here in a sec, but when you create a package, Zarf creates a package with all the specified resources along with an SBOM for each image. We then push all those images to the registry, and we perform a Helm install for each chart being deployed. So even when we deploy like Kubernetes manifests, we also turn that into a Helm install. Shout out Helm, it's been a very useful lifecycle for us. And let's look at some examples, we'll make it real. This is gonna be the simplest possible example, deploying DOS games, pretty much Doom. We have the Zarf package config kind, some metadata, and then where the real meat is very simple, but we deploy a deployment.yaml. It's a Kubernetes deployment, a service alongside a image, and obviously that image is referenced by the deployment. And then we have several ways to deploy Helm charts, from the local path, from an OCI object, from a Git path, and from a Helm normal repo. We pull all of these, depending on the specification you give, into your Zarf package as a tar file. And we also have an example of Flux, which I've mentioned a couple times, first component does the actual Flux install using the Flux release alongside all the images required. And then we have a Git repository with a Git repo, a Helm repository with a Helm repo, and a Flux OCI repository with an OCI repo. One neat thing about images within Zarf is that these images don't have to be container images. They can be OCI, just generic OCI images. So here actually, this is a Helm OCI artifact, not a container image. And Zarf will still push that up to the registry. Same with the OCI repo below. And let's show off an actual example. So we can look at the DOS games package, which I just talked to. We have a standard deployment here. Note that we have the normal ghcr.io registry here and a service that's going to expose the application. So let's go to examples DOS games. We'll do a Zarf package create. It'll be real fast because we have one real small image, and it's going to create this tarball for us. We'll go ahead and deploy that. Going to push that image to the registry. Going to get the Helm install going. And we even have a feature, Zarf Connect, which pretty much does a port forward. And woo, we got the free version of Zoom, only the first level. Don't worry about the legal stuff. So woohoo. And that obviously easy enough to run in the air gap. And if we go ahead and look at the actual YAML for this DOS games deployment, what is it called? Game, there we go. That's in the cluster. You'll notice the image is pointing to this node port service. This node port service is the Zarf registry service. And so automatically mutates it for you. You don't need a separate set of manifests in your air gap. And then obviously we're at a security con, a lot of talk about SBOMs and making them useful, but in the air gap, at least we want them to exist. So Zarf does a SIFT scan for each image on create, shout out SIFT. We use the library under the hood. Because we have the SIFT JSON, SIFT also has built-in functionality to turn the SBOM into different formats such as Cyclone DX and SPDX. Additionally, we have a built-in HTML viewer on deploy, which can be nice, if you don't have much else to use. So let's try that on. So we're going to do the Zarf info. Do I need to create the package here? Probably. Another water break from me. Oh, nice. Zarf also has an OCI cache using Crane, so it pulled all those images super quick because they were already there. And if we go ahead and deploy this package, it'll give us the option to look at here. And obviously we have the SBOM stored in the package as actual JSON, but just to visualize, we have a built-in HTML file to show what is in each of the images that you brought in. And we can also store Zarf packages as OCI artifacts. So shout out ORAS, which is a open source project to allow you to easily deploy packages or easily create your own OCI artifacts and publish them to registries. Zarf, even if you're not pushing Zarf packages to OCI registries in the disconnected environment, it still ends up being really useful to deploy your packages as OCI artifacts even on the connected side. You're probably going to want to share your package between teammates. The package is going to consist of a lot of layers. A lot of the meat and actual megabytes of the package are going to be image layers. if you already have those images in your registry, or you're deploying and publishing multiple versions of the same Zarf package, a lot of those layers are going to be the same. Those layers are going to be decoupled and save space for you in your registry. So it's different than just sending up a tar file as an HTTP request, because at that point you're going to have to store every byte over and over again each time you send up the OCI registry. And it's also just a convenient system to use rather than having to curl and whatnot. Yep. Yep. Yeah, and so let's actually look at the DAG. This is a really useful website for understanding OCI. So we have the index.json that has, this is for the Zarf init package. And so if we click on the manifest, you'll see all the layers here, and they can be any blob. A lot of them are going to be the image layers, and these will be decoupled in a registry between anything that has the same SHA. But we also have the Zarf YAML here. If you look down, we also have any files that you bring in. So yeah, it's a way to decouple and store in a simple way your OCI package. I guess maybe not simple, but simple for the user, right? It's a good UX to, if you already have a registry existing in your environment, you can just reuse it, right? And let's go ahead and publish a OCI package just to show it off. We'll do the DOS games package. I'm going to add OpenSSF to this version so we know what's going on, or we can see it. So just publish that to GHCR. We'll go to GitHub. Check it out. And woo, we got OCI with OpenSSF here. We got the OCI artifact with the OpenSSF tag. So that's pretty much it. Any questions from the audience? Yep. Yeah, so yeah, kind is a single node, but if you make the registry, if you give it a PVC that supports multiple nodes. Yeah. No, yeah, so no, the SBOM is just in the actual Zarf package tar. So we don't really do too much with it. It's kind of up to the user. If you unarchive the package, you'll see the SBOM as a tar file, and it's just essentially a collection of SBOMs for each image. Yes. Yep, it's in the package tar, and we could actually decompress. Oh, you're good. I'm glad you're answering this. You're the perfect person to answer this. Yeah, no, I'm glad you asked that. Because like we do we'll put in the SBOMs, but I think Cameron made a great point to me is like, you want your SBOMs not just to be a compliance tool, you want them to actually be useful. So other people, we're giving to them, other people need to do the work to make them useful, right? Any other questions? All right. Oh, there we go.
So we've been trying to automate the building of the Zarf package. And one of the disconnects that, maybe there's a simple solution to this, but it seems like you have to document the container version twice, right? So you have it in the top level Zarf file, where you have to say, effectively that's telling you to go get this certain thing from somewhere and put it in your registry. But you also have to put it in your manifest file. Seems like it'd be nice not to duplicate that. Is there a way to get around that?
So not exactly. So we do have a tool called Zarf dev find images, and it will give you images alongside like cosign artifacts like signatures. However, we don't 100% know that like because that image is there that you're going to want to bring it into your cluster. I think the pod info chart is a good example where we'll find some images that might not actually be deployed depending on the values. Additionally, you might need more images. So you might have like we've seen operators that have hard-coded images in them, and so you don't exactly know, like with 100% certainty, that the images in the manifest or Helm charts will be there. Additionally, most YAML packages aren't going to handle comments well, so we want the zarf.yaml file to be a declarative statement of what's actually going into the cluster. If we edited or added to it on the fly, it wouldn't exactly be that, and then if we edited it during create, you would lose some comments. So it is something that like we can consider. Like I think ask someone to make an issue, potentially making Zarf dev find images like with a way to edit it into your images section of your zarf.yaml, but we don't want that to be the default go-to for users because we still want that zarf.yaml to be declarative. But yeah, this is made so it can be, it's got the tab space and everything. You should be able to copy paste it into your file. Yeah.
When you do your customized build, it does all that. It'd be nice if you could sort of do something at the Zarf level that sort of handle all that in the same way, where in CI I could say like update image tag, and everywhere where that image tag existed.
Yep.
I think when I get this, I understand how it works.
Sweet. No, it's a fair question for sure. I thought the same thing when I joined the project. Cool. I think we're good. Any last minutes? Sweet. That's it.